Hi everyone. In this video I'm going to introduce the idea of power in physics, and we're going to look at this formula from the Physics Regents Reference Guide. So this formula has 3 equal signs and it has 4 different sections to it, which is not super useful for me looking at it exactly as it is. I really want to format it a little bit differently. I really just want one equal sign in an equation that I'm going to be using. So I can break it down into these 4 different sections, and basically I can set any of these 2 sections equal to each other. So I might have a formula that says P equals W over T. That's a formula that I can make with that longer, more drawn out formula. I could make a formula that says FD over T equals FV, and that would also be true. And it doesn't have to just be the ones that are next to each other. The most common things you're going to see in this class are power equals work per time, or power equals force times distance over time, or power equals force times velocity. Most of the time when we're using these formulas, we are talking about power, so it's usually power equals one of those other 3 things. So let's define power. Power is defined as the rate at which work is done. And it's measured in joules per second, or watts. So we can see a representation of power here. We have a weightlifter lifting a certain amount of weight above their head in a certain amount of time. So if work is a force times a distance, power is that force times a distance divided by time. Basically, how fast can you get the work done? If someone lifts this weight in 3 seconds, they have more power than someone who took 10 seconds to lift it. If we look at this representation, it's kind of a representation of a force times a distance. So a 12 Newton force times a 5 meter distance, which is a certain amount of work. But it's also being done in a certain amount of time, also 3 seconds. So depending on how fast you can get the work done, you might be more or less powerful. Let's talk about joules per second. Joules per second comes from this part of the formula. If power is equal to work over time, then work is measured in joules and time is measured in seconds. So that's where joules per second comes from. It's literally a joule divided by a second. Just like we could have meters per second if we did a distance over a time. But we also name that watts. It's much more common to see W for watts, and that's what we'll generally be using in this class as the unit. So let's take a look at question 1. It says, a motor does a total of 480 joules of work in 5 seconds to lift a 12 kilogram block to the top of a ramp. What is the average power developed by the motor? I'm starting by circling my numbers in units, underlining my unknown, and boxing my keywords. I only boxed the word work because I think that's going to be relevant and help me figure out what 480 joules is. If I were doing an energy problem, the top of the ramp would probably be important, but I know that I'm not doing an energy problem, so I just kind of ignored that. I'm looking for power, so P is my question mark. I'm writing down W equals 480 joules because it says 480 joules of work. Time is 5 seconds, and mass is 12 kilograms. So I want to look for a formula that combines all of that, or at the very least, it has to have power and then some of these. So I've got power, and it could equal work per time, or I could use force times distance over time, or I could use force times velocity. I'm choosing power equals work per time. It doesn't have mass in it, but that's fine. That can just be extra information. So I'm plugging in 480 divided by 5, and that gives me 96 W. Here the W stands for watts because it's the unit for power. Let's take a look at question 2. It says, a 5.8 times 10 to the 4th watt elevator motor can lift a total weight of 2.1 times 10 to the 4th newtons with a maximum constant speed of what? I'm starting by circling my numbers in units, If you don't like to look at the scientific notation, you can plug it into your calculator and kind of rewrite those numbers nearby. But if you don't mind the scientific notation, then you can just keep it like that. I'm solving for speed, so that's what I underlined. And I put a box around weight. Now, it's important that I remember that weight is a type of force, because in all of these formulas, there's nothing for weight, there's just force. So I want to make sure I remember that. So I wrote force next to weight. Let me start listing out my variables. I have power is 5.8 times 10 to the 4th watts. They didn't really tell me that this is the power. It's just my responsibility to know that if a number ends in watts, it must be the power. The force is 2.1 times 10 to the 4th newtons. Again, they didn't even say the word force. That was kind of on me to remember that weight is a type of force. Or you can look at the thing that says newtons and remember that newtons is the unit for force. And velocity is my question mark. So I need to find a formula that's going to have power, force, and velocity. Velocity being the most important, and then probably both of these since it's only two other numbers. So I'm going to choose P and FV. So I've got P equals FV. I'm plugging in my numbers. Again, if you want to change it out of scientific notation, like by putting it into your calculator, you can. But you don't have to, so I've got 5.8 times 10 to the 4th equals 2.1 times 10 to the 4th times V. This is a multiplication here. The 2.1 times 10 to the 4th is being multiplied by velocity. So to undo that, I'm going to divide both sides by this number, 2.1 times 10 to the 4th. You should get 2.76 meters per second, and when you round that, it will give you 2.8 as your answer. The last one I'm going to look at in this video is question 3. It says, in the diagram below, a 20 Newton force is used to push a 2 kilogram cart a distance of 5 meters. The work done on the cart is what? So, of course, I'm going to start by circling my numbers and units. I'm underlining the unknown, which is work. And I put a box around force and distance, because I think those are going to be important variables to use for this problem. We could go back to look at the power equation, but I don't really have any information on power. So let's just start listing our variables. I know that force is 20 newtons. I know that mass is 2 kilograms. And I know that distance is 5 meters, and I know I'm looking for work. At this point, check out your reference guide and see if there's a formula that you can find with W and then some of these letters also. So I found W equals FD, and again, mass is going to be extra information, and that's totally fine. So I'm plugging in W equals 20 times 5, which gives me 100 joules, and that's my answer.